Everyone got a term schedule? I've posted the course outline on Moodle. I don't print those because you guys read them online, right? Even if I printed them, I don't think you would read them. So anyways, here's kind of the stuff that you want out of the course outline. So I've got my contact information on the side, and then I've got the grade breakdown and the test dates kind of highlighted, so you can put those in your phone or whatever. And then kind of a play-by-play of what we're doing, or what I hope to be doing every day. Okay. So I tend to fall behind because I talk too much. So I'm going to try to be better and just kind of give you the goods and get on with it. Okay. So this schedule is kind of subject to change, but it's a pretty good guideline of what I want to be doing. Sorry. Thank you. Okay. So test 1, I just have covers chapters 1 through 3. We're not doing all the sections in chapter 2 and 3. So just keep that in mind. Obviously, I'm only testing you on the sections that we've done. Okay. But for the specific sections that we're doing, you can have a look in the list. Okay. So that's kind of a common question. I decided not to put your assignment due dates on here just because I do want to kind of be flexible. But as a rule, if I give you an assignment, you'll have a week to do it. Okay, so from the day that I give it to you, you'll have a week to do it, just regardless of what's going on. Okay, so you'll always have plenty of time, and then that's why I'm not committing to due dates like I have in the past, because people usually are freaking out. I thought the assignment was due. We haven't even covered this. Yeah, just relax. So that's why they're not on it. So it's just the topics on here. Okay. And like I said last day, right, I've got my office number, I've got my cell phone number, I've got my email on there, I've got my office hours. Like I said last day, if I'm here on campus, you can come see me anytime, right? If you have a question, you're working on something. If I'm not in Ottawa, I'm usually here working on the weekends. So even if it's like you're working on something on the weekend, she can't possibly be here. Yeah, I am, most likely. So you can just text me and see if I'm around, because I am way over in the C building. So who wants to go all the way over there, right? All 7 of you. Everyone else. Oh, I'm still working on the labs, trying to fix the wet conflict, trying to move it to Monday, tried to push that through. Then you guys had a course move to Monday, kind of throwing me for a loop. So anyways, I'm still working on fixing the labs. I do want to get them moved still, so just stay tuned. But again, there's no labs this week, so I've got time, right? Any questions before we start? None? Okay, great. So I'll be boring today and sit down because we've got a lot of writing to do, unfortunately. Ugh. Okay, so I'll just make a little note here. Still trying to fix the lab times. Stay tuned. Oops. Stay tuned. Okay. So, I like to do a quick review. We didn't really get through much material, but I like to start each day with just a review of what we did. well, we did our intros, we did what our assignments were, etc. And then we just talked about a population versus a sample, and also the notation of sample information versus population information. Okay, so we talked about a sample versus a population. And notation for sample versus population information. And I don't know if you've had a look on Moodle, it's pretty sparse right now, right? But I post those PDFs, so that's what you can expect to see. Did anyone check out YouTube for my video? I know you've all been on YouTube, but anyways, so the video from last day is posted there. So if you weren't here last class, then I posted the link to the lecture videos. I am obviously not a good YouTube user. I just started using it last term, but I guess I can make a playlist. So I'll try to do that and kind of get all the Stat 121 videos, Stat 124 videos, Math 114. Right now, they're all just in a big heap, so you can watch whatever you want. That's kind of where we got to last day. Right? And so today, right, we're just gonna keep developing our kind of terminology, a little bit of, maybe not notation, but just concepts about data, right? How do we talk about data, right? We need to be able to refer to the different components in our data set, right? Because at the end of the day, we're just gonna be dealing with a lot of data. Okay, so we need to be able to talk about data sets. We need to be able to talk about data sets. I think we can all agree on that. Right? So usually, right, data is stored in some sort of a spreadsheet, right? And so how I like to approach this is just imagine you have a spreadsheet, right? And then each of these columns would be, so the columns are the ones going up and down, right? Those would be what we call variables, right? So each column would be a variable. Okay? So usually data is stored in a spreadsheet and each column represents a variable. Each row, right, is just each subject that you've taken measurements on. So each row is a subject, right, or a person often, right? Could be an animal or whatever. That's why we say subject, but we think person is a subject or person we have taken a measurement on. So that's all good. The terminology that we need is for these variables, right? We're gonna have different types of variables that we deal with. Okay. So we need to learn, oops. Some variable terminology. So I like to use manatees in my examples because I think they're really cute. And so what I want to do is just imagine that we've got this spreadsheet. So we went out and we looked at these manatees They're just little animals. Actually, they're big animals. And we measured things like their weight, their length, their gender, what species they are, and maybe something weird like the length of their right arm or something. I guess it's a flipper. Doesn't matter. Okay, so we've measured all these things, and now we need some way to be able to talk about each of these variables, right? And so just as an example, right, we've got our observation. We've got manatee number 1, manatee number 2, manatee number 3, etc. And we measured things like their weight, their length, their gender, their species. I don't have room for the last one, so we'll drop it. Doesn't matter. Okay. So these are all things that we can measure, right? And so we call these variables, right? Weight, length, gender, species. These are all variables because they vary from manatee to manatee. And so the first manatee weighs 315 kilos. I have no idea if these are reasonable or not. I made them up once upon a time and never checked them, so doesn't matter. The second manatee weighs, let's say, 450 kilos, 298 kilos for manatee number 3, etc. The length of manatee number 1, say, is 1.5 meters. Manatee number 2 is 2.1 meters. 1.7 meters for manatee number 3, so on and so forth. First manatee is female, and then we have a male, and then we have another female, etc. First manatee is a West Indian manatee. The next 2 manatees are Amazonian manatees. Doesn't matter. WINAA. These are all things that we can reasonably collect. Right? Bless you. So the variables that we have, right? So our variables are weight, length, gender, and species. First thing we can do, right, and so at the very top of kind of our tree is, for a variable, is they can either be measurements, right, like weight or length, right, so any sort of measurement that we've made, we call a numerical variable, or a quantitative variable, or if we have these types of variables, right, where we can see, okay, well, these seem to be categories, right, male, female, and then however many species there are, right, just say what species it is, goes in that category, right, those would be categorical variables or qualitative variables. Okay. The problem with stats is that it's used in basically all fields. I guess that's a good thing. But the problem comes from all this terminology. So some fields prefer quantitative, qualitative. Some fields like numerical, categorical. I'm going to stick to numerical and categorical because I think it describes the groups better. But that's the only reason. But my job is to introduce you to all this terminology that all says the same stuff. so that when you go out into your field, then you can say, oh, that's the same as this, right? Quantitative is the same as numerical, or qualitative is the same as categorical, right? So a variable is either numerical, oops, or categorical. Numerical is sometimes referred to, or sometimes, referred to as quantitative. Right. So quantity. And categorical is sometimes referred to as qualitative. Qualitative. Oops. So we've got at the top of our branch, we can have a variable, and it'll be either categorical or numerical. Categorical is probably the easiest one to kind of identify, right? Because it's any data that can be grouped into categories, right? There could be a large number of categories, right? But it'll always be kind of a finite number of groups. Okay? So this will be data that can be grouped into categories. Numerical variables are any measured value, right? So any measurement that we do, things like speed, distance, weight, I don't know. Any sort of measurement that we do is a numerical variable. Okay. So is any measured value a quick check that you can do is if it makes sense to talk about the average, it has to be numerical, right? We can't talk about the average category, right, or anything like that. And so if it makes sense to talk about the average, it'll be numerical. Okay. So if it makes sense, oops. Merging all my words together. To talk about the average of a variable, it is numerical. Oops. So we can talk about the average weight, the average length, the average sales that you've made, the average number of sales even, right? Average age, all of these things are numerical. So that's just a quick check that you can do is it doesn't make sense to talk about the average. If yes, then it's numerical. Right? So on top of being either categorical or numerical, right, and I'm not going any deeper than that. So Some fields like psychology like to go way deeper into mostly categorical variables, but I'm just going to stick to this level, categorical, numerical, that's it. Okay? But if you do go on into your field, then you might have to go, you know, there's even more ways to slice and dice these things. Okay? Another thing that we could break up our variables by is there's going to be a response variable and an explanatory variable. Okay? Because the reason that we're collecting this data is because we have some research question in mind, right? For example, in this case, right, what's the average weight of the manatees, right? So that might be our research question. So our research question is about the weight, right? We collect all these other things because we may as well, right? And the hope is that if we take into account the length, the gender, and the species, right, then those might help explain changes in the weight, right, making them explanatory variables. And so the weight in this kind of hypothetical would be our response variable. Okay? So a variable can be a response variable another term we could use is a dependent variable. And so depending on, again, what field you're in, but I'll stick to response. I try to do my best to kind of stick to one thing, introduce them in the beginning so that they kind of ring a bell later on, but and then I stick to one thing. Or an explanatory variable. Which is sometimes called the independent variable. So in a research question, the variable we are interested in is the response variable. All other variables are explanatory variables. All other variables are explanatory variables. So for example, if the research question is, what is the mean weight of manatees? Oops, pen's kind of glitching out. Then the response variable, or the response variable, is the weight. And the explanatory variables are the length, gender, and species. So like I said, we collect these explanatory variables, right? Hoping that they'll help explain changes in the response variable. We collect explanatory variables with the hope they might explain changes in the response variable. So later on, we don't get to scatter plots until way later in the course, but they are coming, don't worry. So scatter plot is just a normal kind of XY axis. And you've probably seen something like that. Right? And so how I remember it is that the explanatory variable goes on the x-axis, right? They both have x's in them. So the explanatory variable goes on the x-axis. And the response variable goes on the y-axis. So all variables can be classified as either numerical or categorical, but also as a response or an explanatory variable, right? And so in this case, right, the weight, where did I list them here? Oh, it's been a while. The weight, right, is a numerical response variable. Right? The length is a numerical explanatory variable. The gender is a categorical explanatory variable. And the species is another categorical explanatory variable. All right, so these layers go hand in hand. Okay. So for us, right, our weight is a numerical response variable. Length is a numerical explanatory variable. Gender is a categorical explanatory variable. And species is another categorical explanatory variable. So why is this important? Well, it's important to identify your response variable if you have a research question in mind, right? So that one's kind of, yeah, okay, obvious, right? But the numerical versus categorical is going to be really important because depending on which type of variable you have, that's going to dictate what you can do to this thing, right? How are you going to visualize it? How are you going to analyze it, right? And that's what this course is all about, kind of looking at how do you visualize these things? How do you analyze a numerical variable versus a categorical variable, right? So we're going to go down two separate paths. Okay. So I'll make a note here. All our analyses depend on whether we have a numerical or a categorical variable. Depend on, whether we have a numerical or categorical variable. So we'll kind of let that simmer for a little bit. And we'll go into 1.3 briefly, which is just on data collection. Right, so now we've talked about the names of all these variables. How do we kind of group them? Right. And then, so we're not gonna go into data collection at all. People do whole PhD theses on data collection, how to do it properly, etc. So kind of my take-home message would be, if you have to do any data collection, especially if you have to do a survey, for example, you should probably just hire someone who knows what they're doing. Okay, because there's just way too much, especially in survey design, for us to cover in this course. Okay, so but there's a lot of data that's already available, okay? And we'll see a lot of it, or you'll see a lot of it in the lab, right? We'll talk about that in the lab, right? But there's lots of data out there that we can already use, right? So even if you want to know something, StatsCan posts a ton of data, for example. So there's lots of data that's already been collected. So a lot of data has already been collected. And can be found online. So if you have to collect your own data, right, it happens, then at its very bare minimum, you have to make sure that your sample was randomly selected, right? So I think we all kind of understand that our sample has to be representative of the population, right? And so often what happens if we're just kind of set loose to collect a sample, then we say, okay, well, I need half females, half males, for examples, right? Because that's what the population looks like, right? But that's maybe not exactly what would happen if we did a random selection. And in that case, a random selection is way better, right? Because people have just been selected randomly, and it's just the better way to do things, okay? So if you have to collect your own data, you need to make sure your sample is randomly selected. So I'll give you the definition of randomly selected, and then we'll talk about it. Randomly selected means that each individual in the population has the same probability of being selected in the sample. Selected in the sample. Now there's lots of ways to introduce this, right? So let's say I just had to pick a random sample out of something like this room, pretty reasonable, right? I would just flip a coin, maybe. That's one way I could do it, right? I could go from person to person, flip a coin, heads you're in, tails you're out, right? That kind of thing. That's random because flipping a coin is random, right? Putting everyone's names in a hat, drawing randomly, that's random, right? If I have a bigger list, right, then I could use a random number generator. There's random.org, who claims to have the most random number generator. There's a lot of money put into generating random numbers. Right? Assign everyone a number, and then do my random number generator. Anyone who has the number that was generated by the random number generator gets picked. Those are kind of the simplest ways to pick things randomly. Okay. But like I said, maybe try to at least get help from someone who's done it before for your first couple of times. But most fields kind of have something established that they like to use. Okay. But at its core, everything has to be randomly selected. Okay. So the whole goal, right, is to have a sample that's representative of the population, right? So if our sample wasn't randomly selected, then we can't say that it's representative of the population, right? So whatever conclusions we draw from our sample can't actually be broadened to the whole population, and that's a problem. Okay. So in order for our sample to be representative of the population, our sample must be randomly selected. What is this section called? Weird. I have 1.3 is called data collection, and 1.4 is also called data collection. Not sure what's going on there. 1.4 is sampling, which is essentially the same thing, right? Data collection by sampling. So I think the reason I had the same header is because sampling and data collection are the same, but in my mind, sampling refers to surveys. Right? So sampling, sampling is data collection through surveys. Oops. Most commonly. So if the whole goal is to have a random sample, right, and you're trying to do surveys, that's hard, right? We all kind of know the downfalls of surveys, right? There's things like probably very few of you respond to surveys. I don't like doing surveys. I do a lot of surveys because I just I'm a sucker for that kind of stuff. I've been the one on the other line waiting for survey responses. So, well, not on the other line. I was at my computer. Oh, a survey response. Great. So that's why I do all my surveys. But that in itself is bias, right? Because I do all the surveys, right? And so surveys are really kind of difficult beasts, right, to get a handle on, because you've got people not responding. Are you able to even survey or ask everyone to survey that you want to include in your sample, right? So even then, you're not really randomly selecting people. Remember, the definition of being randomly selected is that each individual has the same probability of being in the sample, right? So if you've got things like, okay, so you're only doing, I don't know, let's say landline surveys, those should probably be extinct by now, they're not, right? But if you're only calling landlines, you're excluding a huge part of your population, right? So they can't even be in your sample. So already you don't have a randomly selected sample, right? So there's lots of ways that you can try to get around it, right? But for surveys, at the end of the day, all you can do is do your best, right? Try to make it as random as possible. Try to reach as much of the population as possible, and try to get as many responses as possible. Okay. So in this case, right, terminology gets a little tricky, because a sample would be the original mail out, right, of surveys. We've talked about the sample as the actual number of people we have information on, right? In this case, for surveys, we talk about the sample as, okay, well, how many people did you try to contact, right? I say mail out, just kind of like as a general term, right? How many people did you try to contact? And then you have the number of responses out of that, which is the actual number of surveys completed. And so if you're doing surveys or writing a report on survey information, right, we have to include the response rate. The response rate being how many actually completed surveys did you get back out of how many did you try to contact, right? Because 200 completed surveys out of 250, that's really good, right? 200 completed surveys out of 10,000 is really bad, right? So it just depends on how many did you try to contact, how many did you actually hear back from, right? And so in reporting survey results, we need to include the response rate. And the response rate is the number of responses over the number in the sample. it is important to report the response rate. To report the response rate. Since 200 out of 250 is a great response rate. Also kind of unheard of. Never had a response rate, I think, higher than 15% or something crazy. But, so response rates are typically very low. I worked for a market research firm down in Victoria, and I worked as a business and data analyst for Valley First, or First West Credit Union, but Valley First down here in the Valley. And our response rates were never that good. So kind of 10% is what you're shooting for. That's like, oh, okay, great, we can continue. So is a great response rate, while 200 out of 10,000 is a terrible response rate. Okay. We need a reasonably high response rate, right? Say 10%, okay, in order to draw reliable conclusions about the data. So we need a reasonably high, like around 10%, I'd say is, I don't know, minimum. I've had to crank out a report with a 2% response rate, and it hurt a little bit, but there are all these kind of caveats. Please note the response rate. These results are not reliable, blah, 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 blah. So we need a reasonably high response rate to draw reliable conclusions about our data. But the whole goal, right, is to collect data to know something about the population, right? And thus the population. So for sampling, right, we've already talked about bias, right? In sampling, so surveys usually, we want to try to avoid bias, right? So any sampling that introduces bias is just bad sampling. So bad sampling is any sampling that is biased. So what is bias, you ask? Well, by definition, it's when you're systematically favoring one outcome, right? Whether that be kind of knowingly or unknowingly, right? That's bias. So systematically favoring one outcome. Yeah. So for example, if you have voluntary responses, so Facebook just puts out an ad and people who want to answer it, or a survey on Facebook, right? People who want to answer it, people who don't want to answer it, they don't have to, right? That'd be a voluntary response. And so already you're introducing bias. Right? You're still collecting information, so if you're okay with that bias, then fine, right? They kind of know what they're doing, but it's not good. Or even convenience samples. So say you quickly have to collect some data for the school newspaper. There must be a school newspaper. I just don't even know. I'm assuming. Let's say there's a school newspaper. And so you forgot about your deadline and you have to collect some data real quickly. And so you just go stand outside here and kind of ask people questions as they walk by, right? That would be a convenience sample. That's not a random selection of the college, right? You're just getting people who have had this class and that class. Maybe that class, if they're leaving at the same time, right? So not the whole college. Okay. Some other things to be aware of. So some other things to avoid, / be aware of. With surveys is you can have undercoverage. So if you can't even reach part of the population, right? So for example, cell phone only households, right? If you're doing a landline survey, you can't reach those, right? Or even the other way around, right? There are homes without cell phones that only use their landlines. So if you're only doing cell phones, then you can't reach them, right? So then there's undercoverage in some demographics, right? Non-response. You've tried to contact them. They didn't do your survey. It's game over. Okay. Even things like response bias. Right. We can, a poorly worded survey can affect people's responses, right? So, well, one, if the questions aren't clear, or if you're leading them through a series of questions that makes you realize, oh, okay, well, I think they're kind of trying to get me to say this, right? That would be response bias. Okay. So kind of included in that, we have to be aware of the wording of questions and even the question order. And so the tricky part, surveys, like I said, they're their own kind of beast, right? And so there's all these things that can go wrong and will go wrong. And all you can do is kind of try to minimize all of this, right? It's going to happen. It's going to be there, right? And it's your job to kind of keep track of, okay, well, all of these things, right? So voluntary responses, if you're using that, or if you have non-response, or if there could be some undercoverage or response bias, these are all things that you are trying to minimize, but also need to acknowledge that it's there, right? And it's affecting your responses, right? And your conclusions. Okay. So let's talk about good sampling and kind of how do we get there? Probably guessed it. It's a randomly selected sample. Right? So you do your best to collect a sample that's randomly collected. So it's a randomly selected sample. So a simple random sample abbreviated in SRS, which you'll see throughout the term, right? Blah, 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 collected an SRS of this, right? Just to tell you that, okay, this sample is randomly selected, so you can assume that at least. Okay. Is the most basic random sample we can collect. So a simple random sample is just that, right? Everyone in your sample was just randomly selected from a huge group. Okay. There are more sophisticated techniques, right? There's way more sophisticated techniques, which we won't really talk about besides mentioning them. Okay. So there are more sophisticated techniques. Oops. Techniques including a stratified random sample, a stratified random sample is when you want to make sure that you target certain groups, right? You divide them into strata, right? Little groups. That's what a strata is. Right? And then you do random sampling within each strata. And so if you want to make sure that you've got a representative proportion from all of BC, for example, right, then you divide BC into strata, right, the lower mainland, the island, the interior, right, north, is usually just lumped into one, right, and then you decide, okay, how many do I need from each group? And then you do a random sample within each of those regions. Okay? So that would be a stratified random sample instead of just picking randomly from all of BC. You can take it one step further and say, I want to do multi-stage sampling. Multi-stage sampling is when within each strata, you divide them into strata again, right? You want to have 50-50 males, females, for example, in each region, right? So now you're breaking up the population first by the region that they live in, right? And then also by their gender. And then you want to have representative proportions from each region. So that would be multi-stage sampling. So as far as kind of surveys, sampling, whatever goes, that's where I'm going to end it. Okay. So in general, there are two ways that we can collect data. Right? We can do it just observing information, right? Or through an experiment. Right? Experiments are a whole different thing, right? Because then we're controlling the environment and we're controlling everything, or in theory, we're controlling all things that are affecting your response variable. Okay. And so there are, oops, what's going on here? There are two ways of collecting data. one, all the ones we just talked about, right? Observational studies. Things like surveys, sampling manatees, those were observational. Even user data, right? If you've got a website or something, you want to analyze the user data, that's just observational, right? You're not doing anything to change the response or to control the response, right? You're just observing, right? Or asking people, right? What's your height? What's your weight, etc. And then just writing it down. So the second way we can collect data is through experimental studies. Which leads us to 1.5, which is on experiments. I think from kind of earlier on, we have a pretty good grasp of what an experiment is, right? Experiment, we're controlling all the factors that are going into changing the response variable, right? And so an experiment when we can control all the factors that might affect the response variable. So if we're controlling all the factors, so every single little thing that might change the response variable, that's the only way that we can establish a causal relationship. A causal relationship being a change in this causes a change in this, right? Otherwise, we're just saying, oh, there's a relationship here, right? Between the manatee's gender and their weight, right, for example. Okay. So experiments are the only way to establish a causal connection between two factors. Assuming you can control everything in the environment. Assuming you can control everything in the environment. So again, experimental design is its whole field, right? It's a whole other field that we could spend 2 years on if we wanted to, right? But as far as for this course, right, experiments, we're just going to leave it at, okay, well, it's when we're able to control all the factors, right, that's affecting the change, and therefore it's the only way that we can establish a causal relationship, right? Any questions? You're like, blah, blah, blah. So much terminology. I know. We forge ahead. 1.6. Hey, that's supposed to be next day. I know. Don't worry. 1.6. It's kind of misleading, these sections, because I often plow through it. And then 1.6 takes 2 days and 1.7 takes 1. So it's a little bit off. But on the term schedule, it looks way nicer this way. Okay. So 1.6, examining numerical data. So like I said, we're going to be working with numerical data, and then we change our focus to categorical data, right? How do we analyze categorical data? So in the beginning, we'll just start with numerical, and then we'll kind of change gears and look at categorical data. Okay. So on our little journey so far, right, we've talked about, okay, well, how do we talk about data, right? What are some of the terminology that we need? And then how should we collect data? Just take home message, make sure it's random. That's all you can do. Okay. So just collecting data. So now we have data in our minds, right? And now what? So now we need some way to kind of first look at our data. What's going on in there, right? Often, I don't know, if you've dealt with data in the past, it's probably been kind of a small data set, and it's usually in Excel or something, and you're just scrolling through and you're kind of looking. But when you're dealing with, say, 1 million data points, something kind of gets lost in there, right? So we need kind of quick ways to just have a look at how our data is behaving, right? What are we expecting to see, right? What are we seeing? And so once we have a data set, we will want to examine our variables to get an idea of what they look like. Okay. We will want to examine our variables . Oops. To get an idea of what they look like. So data visualization is kind of a booming field right now, because it used to just be bar graphs and histograms and pie charts, whatever. But now we can do all these cool things with data visualization, or data viz, as we call it in the biz. But the whole goal of a data visualization is just to provide a clear, just kind of quick way to see what's going on in your data. Okay. So data visualization the whole goal is that it provides a clear, concise summary of your data. So like we said, right, whether we have a numerical variable or a categorical variable, that's going to dictate how we visualize it, right? And so we're going to use histograms, or what we call histograms, to visualize numerical data. Okay. So to visualize numerical data, we will use histograms. And a histogram, let's see if I can grab it from before. Copy, steal it. Oops, January 7th. No. So histogram looks something like this. So here we've got x. It doesn't matter what x is, right? It can be any numerical variable, right? Because we're talking about numerical variables. And so it can be the length of a manatee, for example, right? And so let's say the lengths are between 10 and 40. Not that that's reasonable, but just go with it. And so we have, just imagine each manatee, because it's fun to imagine this. Imagine each manatee has to line up in their length category, right? So manatees between 10 and 15 in length, they go in this category. Right? So we kind of break up our numerical variable into sort of categories, right? Or bins. We call them bins in terms of histograms. Right? So these short little manatees between 10 and 15, they go in this bin. Right? Looks like there's only one of them, maybe two. Right? So here you've got your frequency. So 0, 10, 20, 30 is just how many manatees, for example, are in each bin. Okay? And so then we increase our length from 15 to 20. Not that that makes sense, but whatever. And we've got slightly more manatees in that bin. And then we get to kind of these more common lengths, right? 20 to 25, there's even more. And then 25 to 30, there's the most manatees. Right? And then we kind of step it down and step it down a bit more. Right? And so this shape is so common that we call it the normal distribution. Okay. So this shape is one that we're going to deal with a lot in this term. Okay. You can also call it a bell shape, right? I don't think we can argue that, yeah, if we look at here, we get this kind of bell shape. Okay. So the most common shape of a distribution, right? Because here, what we're seeing is the distribution of x, right? I'll show that, or I'll put that here. Shows the distribution of x. Okay. So the most common shape of a distribution is the normal distribution. I often capitalize it, normal, just because it's a name, right? But you'll see it not capitalized too. Okay. So the normal distribution can also be called a bell curve. Okay. But an ideal normal distribution would look something like this. Okay. Normal distribution. Okay. That's a lot for one day. We'll cut it there. That one's a little slow, I guess. Anyways. So, I guess I don't see you guys till Monday. Weird. Have a great weekend, even though it's only Wednesday.